Hello students, uh, this is the third part of Laplace transform, and in this let's start with unit step function, which is also known as Heaviside functions. The definition of unit step function is defined as u of t equal to 0 if t less than 0 and equal to 1 if t greater than 0. The displaced unit step function is defined as u of t minus a equal to 0 and where t less than a and equal to 1 if t greater than a. So Laplace transform of unit step function. The formula of unit step function is Laplace of u of t. If we apply the Laplace transform on unit step function, then simple unit step function, then that is 1 by s. And the Laplace transform of displaced unit step function, that is 1 by s e raised to minus as. Laplace of f of t into displaced unit step function is e raised to minus as, and Laplace of function of t plus a, and Laplace of f of t minus a into displaced unit step function u of t minus a, then e raised to minus as Laplace of f of t. Students, please memorize this all Laplace transform unit step function formula, because we will use for solving the example of unit step function. Okay, and probably the third and fourth formula is the important formula for solving examples. So find the Laplace transform of e raised to minus 3t into u of t minus a. Okay, so you can easily understand that this example of the unit step function, because here u of t minus 2, that is u of t minus a, is a symbol of displaced unit step function. So this is the form of Laplace of function of t, u of t minus a, and the formula, as you know, e raised to minus as Laplace of f of t plus a. Okay, so for solving this example, first you have to recognize what is the function of t. So please compare both the value, and your function of t is e raised to minus 3t. And what is your a? Your a is 2. Okay, so the value of a is 2. So when you apply this formula for this example, so e raised to minus as, and your a is 2, so e raised to minus 2s, and Laplace of function of t plus a. So what is your function of t plus a? So first your function of t is e raised to minus 3t, and function of t plus a is e raised to minus 3t plus 2. Again, first you have to compare. By comparison, your function of t is e raised to minus 3t and your a is 2. So apply in the formula in the place of a 2, and for the function of t plus a you have to write function e raised to minus 3 t plus a, that is t plus 2. By simplifying, you get e raised to minus 3t into e raised to minus 6, and e raised to minus 6 is constant term, so we can write the outside of the Laplace, that is e raised to minus 2s into e raised to minus 6. For now, Laplace of e raised to minus 3t, and here by adding both the power and by getting minus 2 common, e raised to minus 2 s plus 3, and Laplace of e raised to minus 3t, that is 1 upon s plus 3. Second example, find the Laplace transform of e raised to minus t sin t u of t minus pi. Again, by this you can easily recognize that the given example is of the unit step function. This is the formula of Laplace of f of t u of t minus a e raised to minus a is Laplace of f of t plus a. By comparing both the value, your function of t is e raised to minus t sin t, and your a is pi, so e raised to minus pi s. And for function of t plus a, you have to write e raised to minus t plus a. So minus t and pi, minus t, minus t, pi, plus pi, and for sine t plus pi. Okay, so e raised to minus pi s, e raised to minus pi, and here the remaining term is e raised to minus t into sine t plus pi is sine t. So Laplace of sine t is 1 upon s square plus 1, but by using the first shifting formula, that is 1 upon s plus 1 the whole square plus 1, this is our final answer by simplifying. Now the second function is Dirac delta function. For Dirac delta function, the definition of Dirac delta function is defined as for delta t equal to 0 when t not equal to 0, and integration of minus infinity to infinity delta t dt is equal to 1 when t equal to 0, and the displaced Dirac delta function is defined as delta t minus a equal to 0 if t not equal to a, and integration of minus infinity to infinity delta t minus a dt equal to 1 if t equal to a. Okay, so this is the basic formula of Dirac delta function. But the Laplace transform of Dirac delta function is, the formula for the Laplace transform is Laplace of delta t equal to 1. So when we apply the Laplace transform on Dirac delta function, we get answer 1. And when we apply the Laplace on Dirac delta displaced Dirac delta function, that is e raised to minus as. And the last one, when we apply the Laplace on function of t into Dirac displaced Dirac delta function, that is e raised to minus as into f of a. Okay, so let's check the example. Find the Laplace transform of sine 2t delta t minus pi by 4 minus t square delta t minus 2. Students, here you have given two Dirac delta functions. Example, there is one example, but in one example there is two Dirac delta functions. We recognize by this symbol delta. Okay, so let's start with the example. So this is our formula. Okay, so first you have to compare your this formula with the first term, and then this formula with the second term. So by comparing the first term with the formula, your function of t is sine 2t and your a is pi by 4. Okay, so as per the formula, for you have to just check for the first term. So your a is pi by 4, so e raised to minus pi by 4s, and for f of a your function is sine 2t, so just put a, your a is pi by 4 in the place of t, that is 2 into pi by 4, so sine 2 into pi by 4. Okay, then similarly for the second, first you have compare the formula with the second term, then your function f of t is t square and your a is 2, and as per the formula your a is 2, so e raised to minus 2s, and your f of a, so you have to just put your value of a, that is 2, in your function of t, that is t square, so 2 square, 2 square is 4. So by simplifying we get uh, e raised to minus pi by e raised to minus pi s by 4 when 2 cut, so sine pi by 2 minus 4 e raised to minus 2s, as sine pi by 2 is 1, so we can write e raised to minus pi s by 4 minus 4 e raised to minus 2s. For the next example, find the Laplace transform of t into u of t minus 4 plus t square delta t minus 4. Students, I have taken this example because in this example your first term from the unit step function and your second term is the Dirac delta function. Okay, so we solve unit step function and Dirac delta function in one example. So let's start with the formula of Dirac delta function, that is Laplace of f of t delta t minus a e raised to minus a is f of a. This is our example. So for first one, our function of t is t, and this u of t minus 4, so this is the unit step function. So e and your a is 4, so e raised to minus 4s, and as per the formula Laplace of f of t plus a, that is t plus 4, and your function of t is t, so just t plus 4. And as this second term is the direct delta function, your function of t is t square, your a is again 4, so e raised to minus 4s, and Laplace of t square of 4 delta t minus 4, that is just 4 square as per this formula f of a. Your f of a is t square, so just 4 square. And here the Laplace of t plus 4 and Laplace of t plus 4. So Laplace of t is 1 by s square and Laplace of 4 is 4 by s, and by simplifying we get the final answer of the given problem. Laplace transform of periodic function. So a function f of t is said to be a periodic if there exists a constant t by t greater than 0 such that f of small t plus capital T is equal to f of t for all value of t. This is the definition of periodic function, as you all know. Now this is the statement of the periodic function. So if f of t is a piecewise continuous periodic function with period t, then apply the Laplace transform of f of t equal to, this is the formula of Laplace on the periodic function. So for the proof, let's start with the definition of Laplace transform. So the definition of Laplace transform is Laplace of f of t is equal to 0 to infinity e raised to minus ft dt. Now here for the integration is between 0 to infinity, so we have to part this integration into two parts, that is 0 to t and t to infinity. Okay, so by in the second integral, putting small t is equal to x plus capital T, that is dt equal to dx, because when small t is equal to capital T, x is equal to 0, and small t is equal to infinity, then x tends to infinity. So our limits will be 0 to infinity for x, and now substitute this all value in the second integral. So by substituting this value in the second integral, your second integral will be 0 to infinity e raised to minus s. In the place of small t, you have to keep x plus t and f of x plus t, and your dt is equal to dx, that is dx. So uh, as you know, this function is a periodic function. So f of x plus t is f. See here, f of t plus capital T, that is small f of t. So similarly, f of x plus t, that is small f of x. And here e raised to minus sx into e raised to minus ts. As e raised to minus ts is a constant, so we can put outside the integral, that is e raised to minus ts. Okay, so uh, here we can write it as a Laplace of function of t. Now, if we keep e raised to, this is the Laplace of f of t. So, if we keep the second term in the left hand side, then that is 1 minus e raised to minus ts, Laplace of f of t. And first term keep it same. So, by simplifying, we get Laplace of f of t is equal to 1 upon 1 minus e raised to minus ts, and the integral of e 0 to t e raised to minus st f of t dt. Let's check the example. Find the Laplace transform of function of t e raised to t 0 to t 0 to 2 pi, t running from 0 to 2 pi, uh, and if f of t is equal to f of t plus 2 pi, so your capital T is 2 pi. Let's start the solution. The function f of t is a periodic function with period 2 pi. This is the formula of the Laplace on the periodic function. So here your period capital T is 2 pi. So here e 1 minus e raised to my, here this is capital T, and your period is 2 pi. So put on the place of t, you have to put 2 pi. So 1 minus e raised to minus 2 pi is 0 to 2 pi e raised to minus st function of t dt. As your function of t is e raised to t, so you have to put e raised to t. By adding the power, we get e raised to 1 minus s into t by getting integration, and you have to apply the upper limit and lower limit, and by simplifying you get as a final answer. Okay, now the table value, students, uh, this all are we learn in the part 1, part 2 and in this part 3 about the Laplace transform. Now we learn about the inverse Laplace. So the table of inverse Laplace transform, uh, when we apply the inverse Laplace on function of s and we get answer in function of t. Okay, so when we apply Laplace inverse on 1 by s, then we get the answer 1. Similarly, when we apply inverse Laplace on 1 upon s raised to n, then answer is t raised to n minus 1 upon gamma n, and we can write t raised to n minus 1 upon gamma n minus 1 factorial. For 1 upon s minus a, Laplace inverse of 1 upon s minus a, our answer is e raised to at. And for Laplace inverse of 1 upon s minus a raised to n, that is e raised to at, t raised to n minus 1 upon gamma, and this is the most IMP formula, uh, the second one and the fourth one, and the most IMP formula. 1 upon Laplace inverse of 1 upon s square plus a square, that is 1 upon a sin at. Laplace inverse of 1 up, s upon s square plus a square, that is cos at. Laplace inverse of 1 upon s square minus a square, 1 upon a sin hyperbolic at. And Laplace inverse of s upon s square minus a square, that is cos hyperbolic at. This is the most IMP formula for solving all the remaining method of inverse Laplace. So please memorize all the formula. Okay. Find the inverse Laplace transform of s square minus 3s plus 4 upon s cube. So here this is our f of s. By getting individual divide, s square upon s cube, that is 1 by s, 3s upon s cube, that is 1 upon s square, and 4 upon s cube. So Laplace inverse of f of s, that is Laplace inverse of 1 by s, 3 into Laplace inverse of 1 upon s square, and we can write 4 upon Laplace, 4 into Laplace inverse of 1 upon s cube. Laplace inverse of 1 upon s is 1. Laplace inverse of 1 upon s square is t, and 1 upon s cube is t square by 2 factorial, but here 4 by 2, that is 2. Student, here we use the formula of Laplace inverse of 1 upon s raised to n, that is t raised to n minus 1 upon n minus 1 factorial. Okay, let's check one more example. Find the inverse Laplace transform of 2s plus 1 upon s into s plus 1. So f of s is 2s plus 1 upon s into s plus 1. So 2s we keep as s plus s. So s plus s plus 1 upon s into s plus 1. And here if we keep s plus 1 in the bracket, and by getting individual division, s upon s into s plus 1, that is 1 upon s plus 1, and s plus 1 upon s into s plus 1, by cut this both the bracket, we get just 1 by s. Okay, so f of s equal to 2s plus 1 upon s into s plus 1, we get in the new format, that is 1 upon s plus 1 plus 1 by s. By applying Laplace inverse on both the side, we get the answer e raised to minus t plus 1. First shifting theorem for the inverse Laplace transform. So Laplace inverse of f of s is equal to f of t. Then Laplace inverse of f of s plus a is equal to e raised to minus at f of t. Students, here plus sign, so we get minus sign, and f of function of t. So find the inverse Laplace transform of 10 upon s minus 3 whole raised to 4. Okay, so for finding the inverse Laplace transform, here s minus 3, so we apply the inverse first shifting theorem, and by applying first shifting theorem, when we apply the Laplace inverse on this example, here 10 is constant term, and in the place of s minus 3 we just put s, and we keep this minus 3 in the power of e, that is e raised to 3t, by applying first shifting theorem for inverse Laplace. Okay, so 10, this e raised to 3t because of this minus 3. Now just put Laplace inverse of 1 upon s raised to 4, and Laplace inverse of 1 upon s raised to 4, you have to apply the formula of 1 upon s raised to n, that is t raised to n minus 1 upon n minus 1 factorial, n minus 1 factorial, that is t 3 factorial, and here t raised to n minus 1, your n is 4, so 4 minus 1 is 3. By simplifying, we get the final answer 5 by 3 e raised to 3t into 3 cube. One more example for the inverse Laplace transform. So f of s is 1 upon s square plus 4s plus 4. So that is 1 upon s plus 2 the whole square. Now the inverse Laplace, keep inverse Laplace on both the side. Here s plus 2, so you have to keep e raised to minus 2t. You have plus sign, so you have to keep negative sign. So e raised to minus 2t. And you have to just find the Laplace inverse of 1 upon s square. And Laplace inverse of 1 upon s square is t. So e raised to minus 2t into t. This is the final answer of the given example. Thank you so much, students. Feel free to contact for any query. Thank you.